So welcome, thank you for your time and welcome to this talk for No More NoSQL with SQLAlchemy and ORMs. A brief introduction about me. My name is Patel and I work as a software engineer at Bloomberg. It's been 2 years since I've been in the company and it's super great so far. And I work in a team called Bloomberg New Energy Finance and we do cool stuff in Python with green energy, renewable energy, asset level data, etc. You can talk to me in our booth if you have a chance, and we're also hiring, so that's good news. But today's agenda is about No More NoSQL and SQLAlchemy, and I'm going to introduce the topic, give you guys an overview, and discuss a few advantages. But the main crux of our presentation will be a journey with demoable examples. Is my voice echoing or something?
Yes.
Yeah. I would just take it off and do. You could probably do without it.
Yeah.
Well, the recording won't do.
The recording. Hello. Hello. It's a bit hot in here, it's not. Cool. I hope it's better now. Okay. So the journey that I was talking about, it's going to start with a sample service, and we're going to incrementally, it's echoing again, right? Okay, third time's a charm. Cool. So the service will be using basic raw SQL, and it will be using plain text SQL, and we're going to incrementally build on it to add SQLAlchemy. And once we add SQLAlchemy, we're going to add ORMs. Is echoing again, right? Yes. I'm just going to remove the mic, sorry. Okay. It's okay? Yeah. Can you just let the audio video team know, if using it? Okay, perfect. Thank you very much. Okay, and once we add ORMs, we'll discuss some optimizations, and that's going to be our presentation for today. So let's first discuss what exactly is SQLAlchemy. It's an open source SQL toolkit for Python, which allows you to interact with your database in an object-oriented paradigm. It consists of two parts, the core and the ORM, which stands for Object Relational Mapper. We'll discuss this topic in a bit more detail. So in short, if I would like to summarize this presentation in 5 words, it's no more raw SQL queries. So here's an overview about this. The engine is like the starting point of any SQLAlchemy application, and is the place where we define the host, the port, the username and password for the database. And the DB API, or the database API, is like the driver to your code, which is Python's low-level API used to connect to a database and talk to a database. And the dialect is like Python's object that allows you to talk to a particular database with a particular DB API. Connection pooling would keep all these active connections in memory, and this is like the part that SQLAlchemy uses to connect and talk to a database. But the core of it is the SQL expression language that we're gonna exploit and leverage to build all these queries that eliminate raw SQL text. And on top of this, the ORM builds a domain-centric view of our database, and this will leverage the SQL expression language and the ORM with classes, etc., to write object-oriented code for the database queries. So the core is like the architecture as a database toolkit, and this will let you, connect to a database and write queries to it. And your SQL statements will be constructed programmatically using the SQL expression language. The ORM will provide object relational mapping capability at this point, and this means that your database tables will be mapped to the Python classes. So your columns in your table will be the class variables in your class. This means that a row would be represented as an instance of a class. And it also extends the same SQL expression language from the code. And you can use the SQL expression language to compose SQL queries in terms of user-defined objects. I'll show you an example. So here is like a quick look before using ORMs. I'm selecting a few columns and then joining like few tables as well. And I'm also having a where clause. So it's pretty standard and simple query for now. But like, let's see what happens when we introduce ORMs. Boom. Now, the piece of code with raw SQL text is just converted to a very simple statement where we have. You okay? Yep. Sorry. It's okay. Alright. So it's very really humanly readable and it's maintainable over the long term. So this was just a quick example of what we can leverage with SQLAlchemy. It supports a lot of databases, like almost all the popular ones, like PostgreSQL, MySQL, and ComDB2. A few advantages of SQLAlchemy and ORM. So first and foremost, and this is my favorite one, you no longer have to use like raw and bulky queries in your Python. So the example I showed earlier was like relatively simple, where we were only having 3 tables, but in production level you can have dozens of tables, and your SQL like queries can extend to like hundreds of lines. So over the long term, it can have really great advantages. As a bonus, it also prevents SQL injection attacks because it now uses prepared statements and bound parameters. And migrating your database engines becomes even easier because like the SQLAlchemy core has like an abstraction, and you can use multiple types of DB APIs and dialects. And if you're not a fan of the ORMs, some people don't prefer using ORMs because they're memory intensive, for example. So you can use the core separately and leverage all the advantages such as the expression language. And there are also various loading strategies to optimize performance based on your needs. We're going to talk about this in the optimization section later. And you can also write tests and fixtures very easily because now instead of tables, you're working with classes and instances. So you can mock them, patch them into whatever you like. And like one of the huge advantages is that you can also leverage async I/O with SQLAlchemy. They have an extension. We had covered this in like a workshop earlier a few months ago. But I'm not going to discuss this today. It's a talk on its own. And later, your life becomes easier when you use this. So the journey today we're going to discuss by a sample application called Marketplace, which is a Python microservice, and MarketDB is a SQLite database. And we had implemented this in a workshop using Fast API, and this answered questions like, get the customers of the marketplace, give me the orders of a particular customer, or give me the total cost of an order, etc. And this is a high-level overview of our tables in the database. So we have 5 tables: the customer, address, orders, order items, and item. And all these tables are related to each other. For example, there's a one-to-one relationship between customer and address. And there's a one-to-many relationship between orders and order items. So we're going to have examples in this design. First and foremost, executing select queries. So if you were to do this without using SQLAlchemy, one of the simplest and most straightforward way to do this is using like connection from the SQL API, for example. And here I'm creating a function called getCustomers, and I'm having the execute query function within that, and it's passing a string which is select star from customer. Really simple example. In this function, we're having a context where we are first establishing a connection, we're getting the cursor from the connection, and then we are executing the query. And once we get the rows, we return the rows. So it's like a really straightforward implementation. And this is the result we get. We get 3 customers. So this is how we do before SQLAlchemy. Now we can also have another example with a little bit of complex query where we're getting a total cost of an order, where we are summing up the price of an item with the quantity of the items purchased in the particular order, and then we are passing a bound parameter as well. And the execute query function is the same, and then we are getting the results or a total value. Now to add rows to the table, it's quite similar where you have like a raw SQL text to insert something using bound parameters here as well. And our function will change a little bit, and we're gonna add a function called execute insert query. And the difference here is that we're gonna call connection.commit in this case, because we have to commit rows to the database. And since there is like association relationship between these tables, we also need to insert rows into the order items tables, and we do this by creating another function called execute insert queries. And this time we're using execute many because we want to add multiple rows to this table. So this is how we do it without SQLAlchemy. This is not wrong, we can do this, but let's try to add SQLAlchemy to it and see how we can improve this. So as I said, the engine is the entry point of any SQLAlchemy application, and this has the main source of the DB API connections to a database. So here I'm importing the engine from SQLAlchemy, and we're defining in the string, we're defining a few things. For example, we are first defining the dialect, which is the type of database, SQLite in this case. And then we are also defining the database API. In this case, it's PySQLite. And then in the string, we also have the name of the database in this case. So if you're using Postgres, you would have the host and the username and the password, etc. here too. Finally, I'm introducing this echo equal to optional flag here, which just helps to see what's going on behind the scenes. It generates the logs of the queries generated by SQL. So the connection in SQLAlchemy is similar to the connection of the regular DB API. It provides a unit of connectivity, and it's actually the proxy object of any database API connection. This helps you to execute your SQL statements and also provides transaction control. So here I'm replacing the execute query function with using engine.connect this time. We're getting the connection from our engine that we defined earlier in the previous slide, and I'm just returning the connection.execute of that particular query. Now we don't want to keep a connection running too long, so that's why you put that in a context manager, and it will automatically invoke connection.close at the end. So an example for the first query, which was just selecting all customers. This is our execute query, as I mentioned earlier, and this is the logs generated by the SQLAlchemy. So you're just passing in like the query for now, the textual query, and at the first line of the logs you have a begin statement, which is that always gets logged when there's a new transaction. And then in the second line you have the query itself, which is the select star from customer. And in the third line you have the bound parameters if they are passed. So you're not passing any parameters, so it's empty for now. And at the end we have a rollback. So so an automatic rollback occurs like when a connection is closed after use, and we want to ensure the connection is clean for the next use. Now, we can also pass in bound parameters while using the execute for the connection from SQLAlchemy. So here I'm using customer ID as a parameter, and SQLite is using the column notation. So this is how we do it if you want to pass in bound parameters. Now, we never actually insert these parameters directly into the query string because your code will be vulnerable to SQL injection attacks. So always use bound parameters. So you can also commit data, and the way we do it is that we manually invoke connection.commit. So I'm updating the execute insert query function to add connection.commit, and then since like the earlier query was returning an ID, so I'm also like fetching the ID and returning the result. Now this style is called commit as you go, where we manually insert commit statements in our code, and this is what happens behind the scenes. Now you have the begin in the first line, and then you have the insert into order statement that SQLAlchemy has extracted from the text that we passed in earlier. And in this case, we have the bound parameter in the third line, and then finally, instead of a rollback, we have a commit. So with this, we know that our row has been successfully added to the database table. But if an exception occurs when you add it to your table, there will be a rollback instead of a commit. So yeah, here we are manually invoking commit connection.commit. But there's another style called begin once, where instead of using engine.connect, we can use engine.begin. And in this case, if you look in the context manager, I'm not writing connection.commit explicitly. But still in the logs, you can see a commit is outputted. That's because this is a strategy called begin once, and it will send a commit statement automatically at the end of a transaction. Personally, me and like a lot of people tend to use commit as you go because it's a bit more explicit instead of using begin once. So this is what we've done with SQLAlchemy, but now we can make this even more better by adding some ORMs. Okay. So the first thing to know in ORM is like we have this declarative base thing, and declarative mapping means that the columns of the table map to the class attributes, and the columns of your table are your like class variables. So I'll show you an example in the next slide. But the way to do this is that we create a class called base, and this inherits declarative base from SQLAlchemy.orm. And every class that you create will inherit this base class, and those classes will be your ORM map classes. Yeah. So your map classes are created by subclassing base. So this is the example for customer. So I'm creating a customer class inheriting base, and the first thing I have is the member table name attribute, which is the table name of your table in your database. So it's customer in this case. And then I'm having three columns here, or three class variables named ID, name, and address name. These are the names of the columns in our customer table, and we use the map annotation, which is derived from PEP 484. And this finds out with the data type we pass in. So for integer, it finds out the column ID is a integer. For string, it finds out it's a string. And we can also pass in, the column has nullable field, we can also pass in string or none in the brackets over there.
Is map mainly for the type safety, or is this serving more purpose for map usage?
It's both actually. Using map, you can have like you can derive the data type of the column as well. I have an example which does not use map, so that'll make it clear to differentiate. But then you can also use map column, which returns a column type from SQLAlchemy. And in this map column for this ID, we are passing two parameters, which is the primary key and auto increment. So primary key equal to true, it's kind of means what it says. It says that this is the primary key of our table. And I've added auto increment equals true in this case because when I'm adding rows to my table, I'm not specifically passing the ID. It will automatically get incremented from 1. And the way to access data once you have an instance of the object is quite simple. So if some customer was an instant, to get the name of the customer, all you need to do is say some customer.name. So now this was the example I was talking about. So here I'm not using the map annotation. So when using map, you need to make sure that the variable name is identical to the name of the column, which was ID, address, underscore ID and name earlier. But here I'm having customer underscore name. So that's not the name of our column, but using map column, you can say that the class variable customer name is having the column as name, and it's a type string, and it does not have null elements. So this is how we can do it without using map. Now, as I mentioned, all these tables were related and there were different relationships between these tables. So the way to do that in SQLAlchemy with ORMs is to have a relationship attribute. So this is the address ORM, which is quite similar to customer. You're having done your table name attribute, then you have the ID, flat number, postcode, which are the columns of that table. But then you also have customer, which is a relationship. And it's having the map of customer type rather than integer or string. And this is how SQLAlchemy will understand that there is a relationship between customer and address. So since it's a map of customer and not like a list of customer, SQLAlchemy will know that it's a singular type. And we do the same thing for the customer ORM as well. So first we add a class first we add another attribute called address ID. And in the map column attribute, we pass in foreign key. So SQLAlchemy will know that the address underscore ID class variable is the foreign key to the ID column in the address table. And then we also have a relationship in customer, and we name it address. And this is how we signify relationships. And since we have a singular relationship on both the ORM classes, SQLAlchemy will know it's a one-to-one relationship. Now here, what it looks like when you have both side by side. Now in relationship, I've also passed in a couple of things, which is back populates and lazy equals join. So back populates just helps you synchronize the classes in the relationship. So like if you create a child and it changes something, the changes are also reflected in the parent and vice versa. And lazy equals join is an attribute to specify your relationship loading technique. So here I'm using join key loading, but we'll discuss more in the optimization section. So the way to access data with these relationships is also similar. So if you want to access a postcode when you have a customer instance, all you need to do is use the some customer and then click and then say .address and then .postcode. So parent.child attribute. This is the syntax for accessing data. It's quite intuitive. Now, if you want to signify a one-to-many relationship, you can do so using list of order items in this case. So as I mentioned, orders and order items was a one-to-many relationship. So here, instead of using a singular type, we're using list. So SQLAlchemy will know that it's a one-to-many relationship. Now we've defined all these ORMs and we've joined these tables and then we've added relationships. This will be really useful when you try to query data. It's gonna make our lives much more simpler. So to query data, we use sessions, which is the transactional object for ORMs. It's similar to connection that we talked about earlier, and it also uses a commit as you go strategy. So this means that when you want to commit something, you need to manually invoke .commit. So this is the example for getting all the customers. I'm using session of engine as session in context manager, and then in the statement, I'm just writing select customer, and that's it. I'm not adding anything more. So that's our SQL query, if you will. And we can execute on the session to get our result. The result will actually return like a result object, but if we want the actual instances of the classes, we're gonna call scalars. And since we want all the customers, I'm calling .all. And I'm just returning all these customers. So this is what the output would look like. Here you have a list of customers. notice that I had just mentioned select customer, but address is also returned in like a hierarchical format. So this is the advantage of using SQLAlchemy and making all these relationships. And this is what happens behind the scenes. You have a begin statement, and then in the second line, you have like a select statement which is generated by SQLAlchemy, and it's magic because all you mentioned is select customer, and what SQLAlchemy did is that it created this amazing query and it's joining tables, and at the end there's a rollback which happens every time. So this is the way how we can leverage ORMs. This is the example of the second query where we're trying to get the total cost of an order. So here our query now becomes select item or price times order items or quantity. We are multiplying the price and quantity of items. And we are joining tables as well. You can also specifically join tables in the query using SQLAlchemy. And we also have a where clause. So we are passing the order ID of the order whose total we want to compute. And then at the end, I'm getting the scalar objects, and then I'm summing over them to get the total cost of an order. So that's 30 is the same as previous. And this is what happens behind the scenes. SQLAlchemy, generates the SQL statement, and then this time there's a bound parameter passed in the third line as well, the second last line, which is 1 in this case. Now inserting objects is also quite similar. All you need is to create objects and add them to your session. It's quite intuitive. So this is the function for adding new orders. So since we are adding orders in like two tables, like first you create a new order. You pass in like the customer ID and the order time, which were the columns of the table. And then since there was a relationship between order and order items, all you need to do now is just take the relationship attribute, like so new order.order items, that was a relationship, and then set that as a list of order items. And SQLAlchemy has like init built in, which can help you create these objects by just passing key value arguments. And at the end, once you created this new order, you add it to your session by using session.add. At this stage, the transaction has not been committed yet, and it still remains open, and our object is still in pending state. Once we call session.commit, at this point, we are successfully committing the data to the table. And if there's an exception, a rollback will be and if there's an exception, we'll have a rollback instead of a commit in our logs. So here you can see that SQLAlchemy has generated and displayed insert queries. But in the first one, we are inserting values into orders, and in the second one, we're inserting order items into the order items table. So this is one way where we can leverage SQLAlchemy to just have interactions with the database in a convenient manner. Once we've done this, we can also discuss some optimizations. So first thing to talk is lazy loading techniques. So lazy loading is the default technique in SQLAlchemy, and it essentially means that you're loading objects without loading its related objects initially. So if you're a parent and a child relationship, if you're querying parent, you're only loading the parent. You're not loading the child in this case. And when you try to access parent or child, additional select statements will be committed to additional select statements will be sent to the SQLAlchemy. Now this is helpful when you don't need all the parent and the child objects up front, and if you don't require it instantly. So here's an example. Now in our address relationship, I'm renaming lazy equals join to lazy equal to select to let SQLAlchemy know that I'm using lazy loading technique. And I'm also adding a for loop to print all the addresses of the customer. So I'm trying to access the child attributes of the parent. So this is what happens behind the scenes. So first we have a select statement to get of the customers. And then we have one select statement to get the address of the first customer. Then we have another select statement to get the address of the second customer. And then finally we have one more to get the address of the third customer. So as you can see, if you use lazy loading with like such relationship techniques, it's gonna emit a lot of select statements. So here we have 3 customers. What if we had 100 or 1,000? Or like what if we had 1,000,000 customers? So this is the n+1 problem, because if we had 1,000,000 customers, we would have 1,000,001 select queries. That's because there will be one query to load all the parents, and then there will be each additional query to load all the child attributes of the parent. The way we can fix this is by using eager loading, and this means that we are fetching all the related attributes upfront alongside the parent. So the children and the parents are loaded upfront, and one way to do this is by using joins. So we are adding joins to join all these attributes and load them upfront. So it's useful when you want to fetch all the information about the child in one go. And it also reduces your load to the database because you don't have a lot of select queries. So this is a sample log for eager loading. In this case, I have left our join to get the customer and address. And there's only one query here. Another optimization that we can now do is add SQL functions within our SQLAlchemy query. So if you had noticed earlier that I was getting all the objects and then using Python sum to sum the total cost of an order. But here I'm using func.sum, which is the SQLAlchemy function. And once you do that, you see that SQLAlchemy uses its own sum, like SQL sum in the logs. So if you have like different cast or any requirement for SQL functions, you can also leverage that in SQLAlchemy. Now, another optimization you can do is use hybrid properties. I'll demonstrate by taking the example of getting the total of an order. So to get the total of an order, we first need to get the price of an item from order item.item.price, and then the quantity of the order item. You need to multiply, and then you need to sum the price. You need to sum this for all the order items. Now, here is the order items ORM. We introduce hybrid property over here, and this is not too different than like a normal property. So I'm creating item total function of item total property here, and then I've moved the logic of multiplying price and quantity over here, and we can just simply use this property in our query now, in our example now. You can directly use order item or item total. And hybrid attributes have different behaviors at the class and instance level. So we can't use this exact property in the SQL query now. We need to use a hybrid expression. We take the hybrid property and we call item total.expression over here, and it's a class method. So we create another function like item total, and we say the same thing but in a class format. We use item.price and class.quantity instead. And now we can leverage that. So now we can leverage that in a SQL query. So our previous item.price and order items.quantity have been converted to order items.item total. So this is equivalent of doing it earlier, but it just makes it more simpler to read.
Sorry, please go over that syntax you had in the previous slide, the item total.expression.
This one?
Yeah, so what's going on there?
So it's similar to like hybrid property. So here we are. So you did like the property first.
Yeah, I got the property.
Okay. So this is just like the syntax for hybrid expressions. So since like in the item total, we're using self.item, so we are working with instances of the classes.
You're declaring it as a SQL expression.
Exactly. Yeah.
Gotcha.
Yeah, because in our
So you can use it elsewhere.
Yeah, in our SQL expressions, you can see here we're always using classes. We're using item and we're using orders and order items. So you're working with classes. And we can't use the same property over there. So we just convert it into expression. Yeah, and yeah, that was the example how we do it, and then this is how you can leverage hybrid expressions. Okay, so using SQLAlchemy and ORMs, we've gone from like raw text and we're joining tables and passing bound parameters into like a really structured and readable syntax. And that makes our life much more easier. I've been using this like for 2 years, and it has like made development life and debugging much more easier. My colleague and I did a workshop in a couple of earlier conferences, which was like 2.5 to 3 hours long, where we like take you step by step, and you can follow along with the examples. And there are these. I mean, there's this nice documentation if you go to this link. But and yeah, that's it. You can connect me with me on LinkedIn with this QR code, and if you guys have any questions, feel free to ask.
Put the building link back.
Oh, yes. So it's tinyurl.com/SQLAlchemy tutorial. We have given this in PyCon US, PyData Berlin, and PyCon Italy, and it was a nicer workshop because you guys could follow along in the tutorial. So you guys can access our documentation through this link. And thank you for taking your time and being here. And again, I'm sorry I got a cold. I couldn't.